Hey there, folks. So, this episode is going to be a bit of a hodgepodge mix. I know the last episode was working in a fueled heat source actor, getting things cleaned up there. This episode, I'm still not 100% on how I want to move forward with, excuse me, with the critical components of the project. And that's things like the equipment system, stuff like that. I'm having a lot of back and forth in my head between realism with a large degree of complexity and less realism, less complexity. So I'm trying to come to a decision there on that because it really determines how I move forward with things. But in the meantime, I did want to obviously keep the series running. I didn't want to have any extended breaks in there. So this episode, as I said, is going to be a bit of a hodgepodge mix. We're going to do a couple of smaller just cleanup tasks and some additional things I wanted to add in. So the first thing, for anyone who is fairly observant, is we are in our logger. What I want to do is I want to expand our logging so that it also shows an on-screen message when we're playing in the editor. So to do that, what we're going to do is we're going to leverage a preprocessor define that Epic have put in place. What I'm going to do here, I'm going to do Control F, entire solution, and I believe this one is build shipping. So Unreal Engine underscore or UE underscore build underscore shipping, all capitalized, and we're going to find all. Now this is going to flag in a bunch of things, and you can see a lot of the stuff is files we already have files related to code we've created. Let me just see if I can find one in here that's... just want to show it. That's probably because I'm searching in everything. Actually, this will work. So we've got in here UE if either of these are false. So what it's doing is an if UE build shipping, and actually I'm going to go to definition, see if that'll actually take me there. But anyway, so just a quick explanation of what these preprocessor defines are, is they are something that gets defined, here we go, prior to the code being compiled to like run the editor, run the game, things like that. And that's why it's preprocessor defined. So it's pre as in before, processor definition, and that's before all the code gets executed. And what it's saying here is basically if we are running a debug build, a development build, a test build, a shipping build, the game, the editor, and actually we're going to use UE editor, that's a better one for this. But these are all things that are basically saying the code's going to check, is this a value, and if it is, then we're going to do a comparison and some logic on that. So in our logger, what we're going to do here is right at the bottom, it's going to be if UE editor, and we're going to add an end if to close that off. And this is basically saying if we're playing in the editor. This should, it's saying end if is error because my IntelliSense is being slow. There we go. You can see define UE editor is 1. And that is basically if it's 0 or 1. Boolean, that's a true Boolean. But either way, what this will mean is if we're doing a build that isn't including the editor, we don't want this code to be included at all. Now we want to do a null check for G-engine. So if G-engine, and that's just making sure that we have access to the particular, I believe G-engine is actually a singleton. It might actually, global engine pointer, yeah. So as you can see there with the mouse over, U-engine, pointer, G-engine, global engine pointer can be 0, so don't use without checking. You don't want to use that with the next line of code we're going to put in there, because if you do and it's 0, a null, your code will obviously crash. So we're going to go G engine, add on-screen debug message. Simple as that. So int key, we're not worried about that. I just set that to 0. Time to display, F. It's a float, so I'm going to say 5 seconds, 5.0, up 5.f. F color. Now, you can pick a fixed color for this, but I want to go through and actually have dynamic color based on the error level. We have debug, warning, error, and critical. What I want to do here is up in our private section, because we don't want to use this anywhere else. We're just going to go F color, error level as color. Name this what works for you. We want a const error level, pointer level. And the reason why it's constant, we're not changing anything. We want the reference because we don't want to create a new memory slot for this. It's already in memory. Just use what's already there. Again, memory management is something I'm trying to take into consideration with everything I'm writing in my code. Now in here, it's going to be pretty simple. It's going to be switch on level. We're going to go case el underscore el underscore. No, we want to start with debug. Debug. I'm just going to throw in a break here for now. Case el underscore warning. Case el underscore error. Forgot the break. Break. And then finally, now we could go. Actually, no, I'm going to do it this way. Case el underscore critical. Break. Case. Actually, there isn't a case for this. It's just default. Break. So the reason why we want the default in there, and I actually believe the compiler won't even let you do it anymore. I think it's something that's happened so many times as errors. It's now just built into C++. Without a default value, anything that, if you made a change to your error level enum and we added in, say, I'm going to remove this, but el notify. We added that in there. If we didn't have the default and we passed in a value with notify, it's not going to know what to do. So, but we're going to leave that as default. We're not going to plan on adding anything in for now for new error levels. But we want these to return a color. So we're going to go return F color. Actually, I'm going to copy it with only one. So what color do we want here? Well, debug, I want to be green. I want it to just be a normal message. Warning, I want it to be yellow. Error, I want it to be orange. Critical, I want it to be red. And then default, so if we ever add in a new one, and this is the whole reason for default, if you add in a new one and you forget to expand this error level as color function, you're still going to get something, you're just not going to get in the color you were expecting. Cyan. So now that we've got that, we're going to go back down to our little code we've been adding here. So it's going to go error level as color. We want level to be passed in there. And then we need our message. So that is going to be, well, it needs to be an F string. So we're going to go F string. We want to pass in. Now we have two options here. You can pass in the message that comes in, which is whatever you put in the code, the logger code. So let's take a look at building base. Do we have logger in here? No. Player character though. Not file IO. Player character has something. I know it does. Logger. No, it doesn't. Okay, well, that's just current project, find next. Simple as that. Oh, I have case sensitivity on, that's why. So in here, logger get instance. So we could pass in just this, or print just this here, or you can pass through the rest of the information, which is going to be your date string, current timestamp, your error level is string, which is we've got here, and a new line. Well, we don't need that. We already know, well, it's happening right now. We know the error level by the color, so we don't need, it's happening instantly, so we don't need that information. We don't need this as a string because we have that from the color, so we don't need logline, at least in my opinion. If you want to use logline, you can. So we're just going to pass in our input message in my case. So MSG. Well, that's not going to work because fstring doesn't have a constructor that takes a stud string, standard string. It does, however, have a constructor that takes a C string. So message.c_str, and that just converts it from a standard string to a character string, constant ANSI character string. And really, that's all we need to do. That's everything we've got there to add that in. So what I'm going to do here, we're going to run a build. I'm going to, obviously, when I get there in a second, I'll pause. But so we're going to go through this build. We're going to do a quick test of this in the editor to make sure that this particular code change is working. It should be. I'm 99% sure it will be because of this. This code prevents, obviously, a null pointer, so we don't have to worry about a memory access violation. So. But anyways, okay, so the build succeeded. So I'm going to pause while we go, the editor launches in, and I will be back momentarily. Alright, so we are back in the editor. Real easy way to test this is we can just remove that message manager we added from the scene, and that'll mean our chrono manager can't find it, so it's going to report that. So just delete that from the scene quickly, hit play. And there you can see in the top left, ATF Chrono Manager base, begin play, unable to find message manager. And that's going to cause a bunch of other weird errors, like our time isn't displaying, things like that. So stop on that. We're just going to, not undo history, I want undo delete. Delete element, we'll bring that back in. We'll hit play just to make sure that message doesn't show up. Alright, and there we go. Yes, you'll see the quality of things is pretty sucky right now. I'm not sure what's going on. Apparently, the engine with 554 has been wanting some extra resources. But so that is that out of the way. We've got our on-screen error message. So now, when you're debugging, playing an editor, you can see these error messages that we have been logging. But anyways, next thing we are going to work on. We don't have a huge amount in our to-do list, I don't believe. Come on, task list. No. Okay, well, just while that goes through there, we've got out of bounds logic. Actually, I think we'll work on this one because this is fairly simple. We have, well, I shouldn't say fairly simple. It's not going to be a lot of work. So we have in our AI find flee point. So this is when our AI sees something they want to run away from. We have this little function here that is get random regional point in radius. We are going to execute a call to the engine that is going to be, excuse me, I just want to make sure direction, search location, forward location. We're looking at that. Okay, so what we want to do here is we want to iterate through a couple of different possible options. So while loop with the loop counter, adjust current rotation by X amount to look left and right to find a spot. Option 2, ever expanding radius till you find something. I don't like option 2 because the issue might not be that you're looking too close The issue could be you're looking off the edge of the map. So we're going to go with option 1. So what this is going to be is here's int I equals 0. The reason we're doing that is we are going to be using a while loop. And that is basically, it's as long as this condition is true, keep executing the task. So what we're going to do here is while I is less than, trying to think how many iterations do we want to loop through. So I'm just going to do a quick math here. We could do every 10 degrees and we'd have 36, but that's a little excessive in my opinion. I don't want to do 90 or 45 because those are pretty. Let's do 15. So 360 divided by 15 is 24 iterations. So while I is less than 24, because we're going to start at 0. Actually, we need to start at 1 because, yeah, we need to start at 1 because we've already done directly ahead to where we were going to. We are then going to flee direction.yaw. So we want flee direction dot yaw plus 15 times plus equals 15 times I. And this is just going to work in 15 minutes. No, we don't want to times I because it's going to be very jumpy. We just want it plus 15. And we can actually do this I plus plus right at the start because we're not using that other than to limit. I'm trying to think of anything. I'm trying to think because we want to break. No, we're going to change this up a little bit. Sorry. B success equals false. Okay, sorry. This is not what I had planned out. I hadn't expected to do this, but while not B success, we want to iterate through. We can drop this back to 0. I plus plus. If I is greater than or equal to 24, we want to return the fail result at this point. Oh, come on and tell us sense. Now we could just have equals to 24, but I like the greater than or equal to is in that case if something skips, like somehow we skipped it. So failed. I plus plus, yaw direction, we're just going to add 15 and then repeat this logic. So this is obviously janky and I am probably going to want to refactor this, but just to explain what we've covered here. So we have I don't even know what I'm doing here. We don't need B success. No, we do for the while loop. No, we don't because this return drops us out. Sorry. So while I is less than 24, we're going to do this, so that'll be actually 23 because the 24th one would be back into the original origin spot. So we don't need B success. So this is just an example of how coding on the fly doesn't always work. You want to try and plan some things out, but also some of the refactoring, reevaluating, and changes you're going to make as you write code. Like I say, I do this for profession, and I do this same approach a lot of the times when I'm dealing with an unknown not unknown requirement, but a new set of code. I'm trying to create something that there isn't a previous example in the code base, or the previous example just fails to work anymore because it's old, outdated code, which is my specialty. So, anyways, so just to go through this and explain what's going on. Where we had left this prior was here. It was just basically find a point, reachable radius, return success. If not, we failed. Actually, we need this here as well. No, not cut, copy. So if we did not find one in our first result, what we're going to do is we're going to iterate through a 15-degree rotation. I actually already know how I want to change this, because right now this is just going to go through in a circular pattern. What I want to do is go right, left, right, left, right, left. So I'm actually going to do that for the next episode, just so anyone who's watching this understand that this code right here is going to be replaced in our next episode, simply because off the top of my head I just realized I had a much better way I could do this, and it's actually going to leverage this properly. So, but to explain this is an intermediary step, and again, this is something that you're going to do with your own code. You're going to do this, try it, and like, okay, I can make this better. I can do this in a better way. And this is one of the things I want to show you, which is why I'm leaving this in. This first attempt, yeah, it works, but it follows a clockwise rotation of, okay, 15 degrees to the right, to the right, to the right, to the right, to the right. And at halfway through, it's going to be running directly back towards the target, which we don't want. It's going to want to skip that sort of thing, which we can do actually here. If I equals to halfway would be 12, continue. So what this is basically saying is skip running immediately backwards. But again, like I said, I'm going to refactor all of this because right now it's working in a clockwise rotation. It's not something I want. I want it to sort of go, okay, first one is to the right, second attempt to the left, right, left, right, left, right, left, all the way back until it's almost going back exactly towards the target, or the flee point. So with that though, folks, this is where I am going to end this episode off, just simply because I don't want to try and cram something else in the next 5-10 minutes. We don't have much left in our to-do list to actually cover something like that. So, as always though, folks, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Or you can hop over onto Discord and ask your questions there. Thank you again, and I will see you in the next episode.